I'm Jacob Landseidel.
I'm Tyler Hashimoto. This is Wednesday, the 6 to 10 lab, Kinematic Design and Beam Alignment. So for section 5.1, the alignment of the laser beam, we mounted our Heaney laser in this mount that has tip, tilt, and Y translation. And on top of that, this is sitting on an X translation here. And so once we line it up on the rail, we have an iris in this location, the close location. And once we have the Heaney on this, we'll shine it onto the iris and adjust the X and Y translation of the laser. And then once we move it down, the iris down to the far position, we'll adjust for tip tilt, and we'll just align it through the iris again, and we'll do a few iterations of that, 3 to 4, and it should be aligned to the rail. Good.
For the next part, we use the fact that these two rails are orthogonal to align a 90-degree beam using first the pentaprism here, just aligning it with the iris here, and then secondly we used the beam splitter right here and also aligned that at 90 degrees.
For section 5.2, the co-alignment of two visible lasers, we have a red and green Heaney laser, each aligned to their specific rail. We aligned it the same way using the iris here and moved it for tip and tilt and X and Y translation. We send the red Heaney laser through the pentaprism, which reflects into the 90-degree beam splitter, so then they come here and they converge, overlapping each other. And it looks great.
As you can see, it looks orange when the red and green overlap. So for the Galilean telescope, we first collimated the back lens, which was the negative lens, and we collimated it by shining the laser through the iris, and then the front and back reflections both went back, and so we saw two dots on the iris, and we just combined them, aligned it that way, and we did the same then for the front lens, which was the positive lens, and then the total distance between lenses is equal to the sum of their focal lengths, so plus 1000 minus 50, there we go, and as you can see here, it's aligned.
For section 5.4, beam alignment with the microscope, we had the beam aligned to the rail again, and we actually marked the spot on the paper on the wall back here. And the next job was to align the microscope to that, to the rail, so that the crosshairs in the intermediate image plane would coincide with the spot from the straight up laser beam. And we just did that by adjusting the microscope, by bringing it close to the laser, and adjusting the X and Y, and adjusting tilt to, adjusting the X and Y of the microscope, and then moving it back here, and adjusting the tilt to fit the crosshairs on top of the spot. From the previous alignment that we showed, this was the unaligned spot, or this is the aligned spot down the rail without the microscope. And once we put the microscope inside the beam's path, we'll get an image that looks something like this. And we use the X and Y translation to centralize this beam on top of the pre-aligned spot. However, with the microscope, we have a reticle in that sits at the intermediate image plane, and so it looks something like this. And we adjust the tip tilt on the microscope to align this beam with these spots, so it would look